Hi guys, this is lesson 4 in unit 12. We're going to talk about residuals and residual plot. So last lesson we talked about the predictability of a linear model, and we said that the correlation coefficient, the R value, can measure how well a linear model can predict the bivariate data in a situation. Today we're going to talk about a second way of finding out if a linear model is a good model by using residuals and residual plots, because they can confirm the fact that the linear model is a good model or not. So if one of these two, the correlation coefficient or the residual plot, does not support the fact that the linear model is a good model, that means other models is more appropriate to represent the data. So when we look at residuals, we don't want to see pattern in the graph. If we see a pattern in the graph, that means that the linear model is not appropriate to fit the data, and perhaps the exponential or quadratic model is a better model. How do we calculate residuals? What are residuals? The residual of a data point is defined as the difference between the observed y value and the predicted y value from the equation of the line of best fit. So residuals are the actual value given in the situation minus the predicted value obtained by the equation of the line of best fit. Let's take a look at our first example. Determine if the linear model is an appropriate model to represent the following data using the correlation coefficient and residual plot. And we have this table of value with study hours and the region scores. And we used that example last time when we talked about scatter plot. So the first thing we need to do to be able to determine if a linear model is an appropriate model is to make a scatter plot and find the correlation coefficient. And this is what we can do in the calculator. I already put in the values in the calculators in L1 and L2 after I hit the stats button and then edit to put in the values that we have in the table. I need to find the correlation coefficient, which means I need to run the linear regression in the calculator. And to do that, I need my diagnostic app to be on. So I already turned on the diagnostic in this calculator, and all I need to do is to hit the stats button, go to calc, and then 4, and run the regression. I have L1 and L2 in X and Y list. The frequency list is supposed to be empty, and all I need to do now is to find out the equation. So the equation for the line of best fit for this situation is going to be 6.27 x plus 49.78 if we're rounding to the nearest hundredth. And the correlation coefficient value here is 0.85, which suggests a strong correlation based on what we learned last time. So all we need to do basically is to find out is if the residual plot is going to support this fact. So to do that, I need to put the equation of the line of best fit in y equals. So I'm going to put 6.27 x plus 49.78. And then I need to look at the scatter plot. So I'm going to hit second, y equals, to make sure that my plot is on and that my L1 and L2 lists are in the plot, which is right here. They're there. All I need to do now is to hit zoom 9 to be able to see the scatter plot along with the line of best fit. Okay, so this is what we said. This is the scatter plot and the line of best fit. Now the residuals are going to be the difference between the actual values right here, these are the actual values, and the predicted value, which is on the line of best fit. So residuals are basically the difference between the line and the point, the line and the point, each line and each point. These are the residuals. So basically, to be able to find the residuals, all I need to do is to find the predicted values from the line of best fit. And to be able to do that, all I need to do is to go to second graph in the calculator. And since I have the equation in y1, I have all these values, the predicted values right here for all the x values that we have in the table. So all I need to do now is on my table to make a column for the predicted value and put in the values from the calculator in the table of the equation of the line of best fit in this table. And then after that, the residuals are going to be the difference between the actual value, which is the region score, and the predicted value, which is the value that we got in the calculator. So basically, all I need to do is to subtract the actual, the predicted value from the actual value, and then that value, that difference is going to be the residual. Again, for every single point, I need to subtract the predicted value that I got from the equation of the line of best fit from the actual value, and the difference is going to be the residual. And now to make a residual plot, basically all I need to do is to graph the study hour value and then the residuals that we have at the last column in this table. So to make a residual plot, I do not need the two middle columns. So to make a residual plot, this is what the plot is going to look like. We have the study hours on the x-axis, we have the residuals on the y-axis, and you have to label the y-axis with the word residual to show that you're doing a residual plot and you're not doing a scatter plot. So after you graph the study hours and the residuals, this is what the plot is going to look like. As you take a look at this plot or residual plot, we'll see that we have no specific pattern. No specific pattern for this plot, which means that the residual plot support the value of the correlation coefficient, and that the linear model is a good model to represent the data in the table.